The proceedings are still on their way.
Ansonsten der nächste Vortrag ist Beeinflussung durch künstliche Intelligenz. Es ist ein Einführungsvortrag.
The talk will be by Karen Ulrich and Hendrik Hoyer. Karen works at the University of Amsterdam and Hendrik at the University of Bremen.
Die Karen, sie forscht in Amsterdam an maschinellem Lernen.
Karen researches on machine learning, and Hendrik is doing academic work on human-machine interaction in Bremen. Please give them a warm welcome.
Ja, vielen Dank. Moin erstmal.
Thank you very much. Good morning. Welcome to our talk, how artificial intelligence is impacting our daily lives. We would like to start with a quote from Kate Crawford, the founder of the AI Now Institute. She is principal researcher at Microsoft and a professor at NYU in New York. And she once said this year at a symposium that humans fear that computers are too intelligent and will conquer the world. But actually, and that's what she says, computers are dumb and already have conquered the world. So we would like now to draw on a couple of examples. Some of you might know them, but we're basically aggregating them to paint a bigger picture of the phenomenon. And why are we talking about banality of the approach? Because some of the systems that have been designed are actually pretty simple. And we'll see how they impact our lives during our talk. So, a couple of words about ourselves. Karen is researching at the University of Amsterdam, Bayesian methods and deep learning at the University of Amsterdam. And I'm a research assistant at the University of Bremen, and I'm focusing on human-machine interaction and especially trust issues. We would like to start with an example that most of you will know. It's about detection of spam. Sometimes it works, sometimes it doesn't. We would like to look at the technical setup behind it, which is actually a quite astonishing one. And the difference that we would like to talk about is imperative programming and machine learning. The first, imperative programming, is basically what everyone would think of first. It's imperative programming in a way that it's very absolute. So if Viagra is written as here in an email, then it's a spam email. Otherwise, it's a good, valid message. And machine learning is a different system of predicting. It's an iterative system, and we're looking to predict whether or not an email is a spam email. And this is done by looking at a lot of different examples and classifying them if they're spam or not. And this is being calculated with a resulting error. So if you actually change the parameters that led to this error calculation, you can also, of course, change the error and minimize it, which is a known field of research in itself. And after this, you go back to step one and can basically, in iterative circles, change the outcome of the process. So this is not as absolute, as the algorithm doesn't have to, in this example, first need to really detect whether or not something is spam or not, like in the imperative programming case.
hier die Erkennung von Brustkrebs.
We're continuing now to medicine as a field and the detection of breast cancer.
Das heißt, Charakteristika
So we have different features that distinguish benign and malignant cases of breast cancer, separated
Symmetrie und die Zahl
by a couple of features like curves, points. Some examples are shown above.
Und wenn wir jetzt zwei Charakteristika, wie zum Beispiel die durchschnittliche Zahl der
So if you take two characteristica, for example, the number of points and
eine deutliche Tendenz.
as a first one and the pixels as a second case, you can see that there's a separation, a line of separation, indicated here in blue and red. So mathematically, you can basically draw a line through this data set, and that's called a decision boundary. Doesn't need to be linear, could be more complex, and usually it is more complex actually. So this approach is kind of an analog approach to what actually a doctor would do. They're learning and drawing on their experience and then decide whether or not something is benign or malignant. And the big advantage of machine learning is that we can draw on a huge set of examples and have a better line of distinction based on a huge number of examples. And you can also see that there are a lot of red cases to the right of the picture. And this means that very often we're actually making errors when predicting breast cancer. And very often that actually
gutartig ist und sie auch entsprechend behandle, kann das deutlich schlimmere Konsequenzen haben. Das ist jetzt natürlich
So if I have people that I tell that they have a bad breast cancer and that they actually have a benign breast cancer, they might be very stressed.
Vorher wollen wir noch einmal die Wirkungsmacht von Big Data zeigen.
Before we continue, we want to talk about the power of big data. And what we want to do here is to look at personality markers. We use data that is very easily accessible, but that can be used to have to predict very complex personality markers. For this study, they had a lot of volunteers that gave their Facebook profile with all of the likes and all of the information, like their sexual interest or their religion. What the researchers did was to use a very simple model, a simple regression model, to predict, based on the likes, what personality markers could be detected. With an accuracy of 95%, you could detect whether somebody was white or Afro-American. The sexual interest could also be detected with a very high accuracy. The political interest, the religion, and also the experience with drugs, or the form of the family and the parents in the youth.
Ist es relativ wenig mit der Genauigkeit, ist ja eine 50-50 Chance, wenn wir beraten würden.
Predicting the experience with drugs is not as easy as predicting your gender or sexual interest. We show this because it gives a lot of possibilities of discriminating people. What we want to show here is that we have to think about privacy, because you can detect a lot from just very simple data. Using this model, you can find likes that are very, very important for a specific personality marker. You can think about this for yourself, which of these pictures is related to the intelligence, and which of them is more about the sexual interest.
Das Spannende ist, dass sie ja relativ nah dran ist am Kernversprechen von so.
And the interesting thing is that this approach of looking at pictures and basically drawing conclusions about the personality features associated with them is kind of comparable to approaches that also companies like Google are approaching. So basically, we're using big data to detect humans and single persons.
Zum Beispiel in einer großen Menge von Wählerinnen jene zu finden.
And this kind of research can also be used to, for example, identify people in a pool of voters that are more likely to be convinced to vote for your own party.
Bundestagswahl gab es ja auch eine große.
And this also has been covered by the media in the general public in running up to the German election, but also in the context of the Trump election in the US. We think this is a very likely use case.
Das ist dadurch so eine Art Diskriminierung 2.0.
And we've also seen that this has enabled kind of a discrimination 2.0. For example, if an employer can detect or predict whether or not an employee is homosexual or not, and then draws his own conclusions. And this discrimination actually can be more concrete, and we can see this in the legal system in the US, where actually it is being predicted whether or not somebody will fall back and recommit basically a crime after being sentenced to jail. And here there's a example. To the left there's a man, VP. He has done two crimes, robbing a store, and to the right there's a woman. She has committed 4 different cases as a minor, being less than 18 of age. So both of them, a category is being allotted. To the left there's 3 low risk, to the right there's 8 high risk. And what actually happened in reality, what we're looking at is a prediction, remember that, is that the guy to the left immediately committed a new crime after being released, and the woman to the right didn't. So in this case, the prediction was wrong and also discriminatory in a way, because the woman right is a woman of color. And we also know this from statistics. We're distinguishing this there between type 1 and type 2 error. The type 1 error means that the person that is being predicted with a high risk is likely to commit a crime, and type 2 means
Type 2 error is that a person is predicted with a low risk, but actually does commit a new crime. Here the probability is the other way around. White people have a higher chance of falling into this error than people of color. So how does this happen? We assume that those are good programmers who have learned their stuff and know what they're doing. What you want to learn is a function that goes from x to y. The problem is that X is not a sample from the population, but instead just the people that have seen by the police. So it's not representative. This could be a self-fulfilling prophecy, because maybe black people might just be checked more often, and maybe that leads to a bias in the data set. On the other side, the prediction is also biased, because it is based only on people who were processed by the legal system. So you also have a Y prime.
dann kann auch dort
If you have a jury in your legal system, then this discrimination might be more or less extreme, depending on the people.
mathematische Modelle zu einer Art Geldwäsche für Vorurteile. Weil sie fallen in dieses
What you can
System
do with machine learning is build a system that kind of hides this
Hier
discrimination.
kommen wir jetzt zum Element der direkten Beeinflussung.
So let's go back to taking direct influence.
Hilfen verkauft, die halt nur
Those systems are sold as
werden können,
tools that can be used to help you in predicting crimes.
direkt auf diese Systeme.
But the problem is that the people that use these tools, they trust those algorithms.
Feature von Thomas Schimmick,
There's another example from the Deutschlandfunk,
Veronika Hiller, die Bewährungshelferin,
where
die dem Richter im Endeffekt ein Strafmaß vorschlägt, interviewt. Und das Spannende ist,
Veronica Heller, who was working for the legal system and was suggesting a punishment for
was wir einfach zeigen wollen,
the
ist, dass es hier um soziotechnische Systeme geht. Das heißt, es geht nicht nur um das Machine Learning, es geht nicht nur um den Algorithmus.
the problem is it's more about social things and not just about the machine learning, because even if the system would be fair,
Heißt es immer noch nicht,
it always means that the results must not be interpreted in the fair way.
für jene, die solche
People
Systeme bauen,
might still make errors.
einige heute hier.
And there are probably a lot of people here who build these systems. The bias
Zum Beispiel hier ein Beispiel
based on these data is everywhere. This is an example from Google. We were searching for 3 white teenagers on the left, and on the right we were looking for 3 black teenagers.
Technologie offenbart hier gesellschaftliche Probleme,
Technology shows societal problems.
die eine bestimmte Weltvorstellung festschreiben,
We have socio-technological systems here that show a problem view but can also enforce them.
aus der statistischen Übersetzung zeigen.
There's another example here from statistical translation.
Sprache nicht
You have to know that the Turkish language does not differentiate between different grammatical genders, as German language would do.
Translate oder einem anderen statistischen Übersetzer
So if you then use Google Translate in this example and translate,
hin und her übersetzen,
he is
stellen wir fest, dass die Übersetzung bestimmte
he's looking after children and she's a doctor,
geben, was ihr bisher über Machine Learning gelernt habt in diesem
then the gender
Vortrag,
does not show up in the Turkish language. But when you translate it back, the gender was mixed around the other way. So the doctor was suddenly male and the babysitter
wenn
was
wir übersetzen, dann
female.
berechnen wir ja Wahrscheinlichkeiten.
So what we do when we translate is we calculate probabilities and then just use the most probable result. So even very minor
Ein Arzt
errors can be
sieht so aus, wie wir sie gerade
reinforced, and then you get these problems that we've seen here.
ist. Aber welche Auswirkungen hat das auf
But this can be explained technologically, but what does this mean for the worldview that you get from using a translation service like this? Okay, our next example using Facebook shows how transparent or intransparent this influence can be.
gleichzeitig Produzenten und
Facebook is a very social system where users are both
jedem
users that are consuming but also producing content.
nach eigener Ansicht
Facebook always wants to show the users relevant stuff and uses a lot of data.
Das heißt, wenn ihr jetzt vorstellt,
That
Median, das sind jetzt Zahlen aus dem Kosinski-Paper mit den Persönlichkeitsmerkmalen. Das heißt, da haben im Median haben die Leute 200 Bekannte und
in this example from this paper, people have
das heißt,
200
jeder Dritte was
friends and like
pro Tag 19
80
potenzielle
pages.
Beiträge.
So if every third person does something, there are a potential of 90 posts.
Die chronologische Darstellung ist
A chronological
unumgänglich.
view is not very useful. So Facebook is sorting the posts using an algorithm.
Aber ist dieser Vorgang sehr intransparent.
The problem is that this process is very intransparent, so the users don't know and understand the algorithms, and they think that if you talk to them,
Objektiv und
that the algorithms are objective and independent.
kommt aus der KI.
And I'm talking about this study, which is from the computer interaction community,
waren sich 62,5% der Teilnehmer
and 62.5% of the volunteers in the study
von Newsfeed-Algorithmen, also von dieser algorithmischen Kuration, nicht bewusst.
did not know about this news curation.
mit 40 Teilnehmerinnen,
There were 40 volunteers, and
repräsentativ sind für die US-Grundgesetze.
they are representative for the US population.
Nicht bewusst, dass überhaupt irgendwie sortiert wird.
25% did not even know that it was sorted at all.
Dass die Teilnehmerinnen durchaus verärgert sind, wenn sie Posts von engen Freunden,
The users are also angry if they don't see posts from close friends and family members.
Teilnehmer suchen den Fehler eher bei sich,
The interesting part is that the volunteers are looking for the problem with themselves or other people, but not with the algorithm that Facebook uses.
Bekannte bewusst Geschichten.
They think that their friends don't share stuff with them because they are not very close friends, they don't know each other very well.
Always assumed that I wasn't really that close to
That's why we have this quote. I always assume that I'm not very close with this person, so what the hell? I don't see their baby photos because I don't know them very well, but actually the person shared their photos with everybody, but the algorithm took the decision to not show the photos to the other user.
Schatten agieren,
So these systems that operate in a hidden,
zwischenmenschliche Beziehungen
they have a very huge impact on
machen, diese
interhuman
Nachrichtenempfehlungssysteme eigentlich erreichen.
relationships.
Sind ja
So
von der Art
what
her
do these news systems actually achieve?
Portal,
So
angucke, und ich gucke mir jetzt
other examples on Netflix or YouTube, if you look at some videos, and 4 of them are with funny dog puppies, and the algorithm decides to, oh, he likes dog puppies, let's show him more videos of funny puppies.
Und von denen geht es in vielen darum,
So if I look at 10 videos, and in 4 of them
von kriminellen
refugees are criminals, then the system will
meiner Welt waren.
show me more videos of that type, so it will change my worldview.
Und Echokammern
So those filter bubbles and echo chambers, they
natürlich auch im echten Leben,
get created online, but also in real life with your friend group,
geteilt werden.
where certain worldviews are shared. But on the interweb, they're more transparent.
Logo.
So they're all under the same YouTube logo.
Probleme, denen wir uns stellen müssen, mit denen wir umgehen.
So those are problems that we have to solve.
Das war mein Teil zur Perspektive
And this concludes my part on the human-machine interaction, a field that's affected, concerned with those questions.
mal technisch ins Detail gehen.
And I would like to hand over now to Karen, who will focus more on the technical side of things.
Ja, zum ersten Teil
Yes,
der
hello.
Präsentation zeigten wir, dass
So,
Algorithmen uns schon heute beeinflussen.
We've now already shown that algorithms are impacting us already today in our daily lives, and we've seen to what extent this happens once they have been set in place.
Wir haben auch bereits angedeutet,
And we've also seen
dass man Vertrauen nicht unbedingt
that
angebracht
they don't necessarily actually deliver what is being put into them in terms of trust. And now we would like to actually
auf ein Wort eingehen,
show you
das wir bereits viel verwendet haben.
in what cases this is especially not recommended to trust an algorithm.
Grundsätzlich in zwei verschiedene Formen von Bias unterscheiden.
And what's important here is something that we call bias. There are two biases. One is the bias of data, our own values, value judgments, whether or not we know them or not. That's the first category of a bias. And the second one is the bias of the model. So when a population is misrepresented in the data that is the basis of the algorithm. So what engineers build into the algorithm to make the
Dabei
predictions.
kann sich wiederum der Bias des Modells so auf die Daten auswirken.
In this process, the bias of the model can actually reduce the bias of the data.
Den Bias in den Daten verstärken. Auf der anderen Seite,
At the same time,
Bias in den Daten,
it's also possible that the bias of the data is impacting the model bias. And we'll show you now 4 different examples showcasing a couple of these biases.
bei der algorithmischen Wahrnehmung erzielt.
And machine learning
Algorithmen bewältigen kognitive
has made a lot of progress in the last years,
hat aber auch eine Welle von Forschung ausgelöst.
and also respective research has been triggered by the success of artificial intelligence.
Diese Welle ist im November
One of
letzten
the studies of this latest research is elaborating. It's done in Shanghai. And this research is claiming that you can detect criminals by looking at their passport photo. And we will now focus on this because it's contradicting other research findings, basically using socio-economic context to predict your potential crime rate. And what those researchers have done is they've taken 1,800 photos of Chinese citizens. 700 of these photos were depicting criminals, so people who have been sentenced for a crime. And 1,100 photos were randomly selected from the internet, from sites like LinkedIn and other sources. And let's have a look at a couple of data points to actually see what this study dealt with. So here we have 6 examples, 6 images, and one row consists of pictures of criminals and one of legally people who have not committed a crime. I would like to now do a vote. Please, left or right hand, whether you think the top or the bottom row is non-criminal. So most of you probably think that they can identify the ones who have committed a crime. And somehow we think we can predict this by looking at a couple of data points. For example, his shirt or a slight smile. And in contrast to this, there might be a strong light put into your face, like when a picture is being taken from you in prison. And on the other side, there's a makeup or Photoshop even being used to tweak your picture used for a resume or an application. So the algorithm is, for example, detecting whether or not Photoshop has been used on a picture. And this is maybe an extreme case of how data is actually impacting the outcome of an algorithm. So that's data bias.
Bias kann aber auch entstehen ganz zufällig, wenn zu wenige Datenpunkte vorhanden sind, verlässliche Aussagen zu treffen.
So there's the sample can be screwed, and also the data can be biased by the amount of data that is used to base the algorithm on. And there's also a reporting bias in this case, basically when data is being, when and how data is being identified for the algorithm. And also the modeling assumptions are important in this context.
So before the hype, there's been this no free lunch theory. No possible model would work in that scenario, and so we would have to change our assumptions, looking at a specific problem and use limited assumptions. But then, without the model showing that it's not adequate, it fails nonetheless. And so it's our job as scientists to point out these cases and to really check whether algorithms are valid in a certain case or not. But so the success so far of machine learning lets us forget these rules quite easily. We tend to think that models are so flexible that there are no limits anymore. But
Und das ist das Problem.
And I want to point out an example that still hasn't changed, even though we've had this deep learning hype, and that's goal setting. So what is success? Hendrik already talked about mistakes and a correction of mistakes that we need to do to train algorithms, but it's often the case that we don't really know what exactly is a mistake, and that's up to the engineer to decide. So, for example, on YouTube, they know how many people, how long people spend on their site, but maybe there's not even a person in the room with the computer, but the computer is still, still has YouTube open. And also with clicks, it might not necessarily mean that a person likes a certain video. So just imagine we have a data set of translations, and we want to measure whether text has been translated correctly. How can we test that? So word by word or paragraph by paragraph. If we use a word-for-word measure, then that doesn't work through too many languages. Then paragraph by paragraph, that might not work as well because maybe the algorithm doesn't have the right context. And then what about synonyms? Like, is that depending on the data set, that might be interpreted differently by the algorithm. And so that means we need to make decisions. At Google and other leading translation software companies, they translate sentence by sentence. They tend to think of sentences as independent and only the most predictable word gets computed. So back to our example from the beginning. She's a woman, she's a doctor, and then we translate it into Turkish and then back again. Then we get, she's a woman, he's a doctor. And now we see how this happens. The algorithm doesn't know about the context. So he only the algorithm only translates the most frequent occurrence. So it's not necessarily bias within the data, but bias within the assumptions that simplify the model we use way too much. And something else, if we change the period to a comma, then the algorithm is suddenly able to correctly translate because it knows about the context. So another example of this bias phenomenon, how can bias be
aktives Lernen funktioniert wie folgt.
Get bigger over time. We have active learning. That means there's data on this databases we train an algorithm, but we're not quite sure about something, so we ask a human expert. And then there's always the question of, have I correctly treated this data point? And then the algorithm gets more data in the future to learn better and to not have to ask the human being so often. And this works well, but what about a data point that is described, not correctly described? And then, of course, we have human beings that are not as perfect as we like to think. So we have the assumption of perfect data and a perfect human being in this model, but that leads to this wrong data point being ignored. And so the cause of distortion isn't visible anymore, and that leads to more distortion. And then, of course, if we have more distorted data, then they keep on piling up because there's the human being assigned to the task doesn't even know about it. And so, of course, Google and Facebook, the big players, aren't transparent most of the time, but this might be an example where something like that might have happened. So we have an African-American woman, bottom row in the middle, and she's assigned the term gorilla. And of course, this was quite huge in the media, but Google didn't quite explain exactly how that happened. So, first of all, it might be that the description is always provided by human beings, and they might, just like to troll, but still, that might not be an adequate explanation. Groups of people in our society might be marginalized, and for those marginalized groups, they very often are not included in testing procedures. And we can also think of Microsoft's Tay chatbot that was brought very quickly to write racist messages. And so transmitting learning, there's an exercise for the algorithm to make it learn, but there's too little data to actually get it to learn. And so we have another kind of exercise to help our original problem with more data. But this, again, leads to distortion, leads to bias. So, for example, if we have robotic arms, a hall full of robotic arms, 1,000 of them, they're not that good at learning. So what happens in modern robotics is that you have your systems being trained in models. So that's not reality, but for example, surrounding lights and of course the idealized version of a robotic arm, that's not true to reality at all. And so, of course, the future with self-driving cars, more space in cities, more fluent traffic, and all the promises that come with that, we can be quite skeptical about that because, of course, self-driving cars have been trained mostly in models and not in reality. And so data points, they can be close together or can be very much distant from each other. And to find new data points, that is called interpolation. But find data points outside of that frame is called extrapolation, and that's not very easy to do. And interpolation, going from one or more data points to another, can answer important questions. For example, how would the child of Kim Jong-un and Donald J. Trump look like? What would that look like? Also, the changing video, for example, this is Photoshop, well, an edited version of a porno with a face of the Wonder Woman actress. And so, of course, there's lots of possibilities. You don't want to think too much about that. And there's cases where we also don't want to make a wrong assumption, but this is really hard when we talk about extrapolation. And modern science still hasn't found the right answers for that. And so what we need to remember is that algorithms make these assumptions, and that can even lead to hostile attacks on algorithms. For example, you take a data point from a data set, and then you have their properties, for example, traffic signs, and then find a very similar data point that the algorithm treats as something completely different. And the spooky thing is that this even works with printed versions of the same attack, even if you don't know, even if you don't use the same model or the same data set. So if you're interested in that, please stay for the next presentation. In conclusion, I really want to point out that in all systems of modern machine learning, there's an evaluation of correlation going on. It's not about causation. Mathematical
Für komplexe Systeme
causational research of cause and effect in systems is very much a new field, and the description of correlation is just one of the steps necessary for
haben Henrik und ich noch
that. So before we go over to the Q&A session, Hendrik and I still want to point something out. We really hope we pointed out the limits of machine learning,
als Gesellschaft aber nicht davon abhalten.
but of course that won't
Also denken wir da an Medizin,
keep us as a society from reaping the benefits of this new technology. So in medicine, biology, and of course that raises political questions that concern us all. So these aren't decisions that scientists can, should,
konkret
or must make on their own. So who's responsible for making decisions? Human beings or machines? Is it about engineers or corporations? When who's at fault? And how can we actually enforce existing laws when confronted with this new reality of algorithms? And how and why should they be regulated? So thank you very much for your attention. And yeah, let's hear some questions.
Vielen Dank, Karin. Vielen Dank, Henrik.
Yeah, thank you very much. We're now opening up the round for questions. Please line up at the microphones. Micro 1. Thank you very much for the talk. Really interesting. I think this is a really important subject and how we deal with it, especially because it has real impact on politics and mobilization and all those things. Henrik, you mentioned artificial intelligence and its application to, let's say, political propaganda, Cambridge Analytica and so forth. And also, as a second topic, the filter bubbles that you mentioned. And I'm interested in especially one question in the context of Brexit and the Trump election. What are the possibilities, the options that are there to actually oppose and counter that opinions are being echoed and even strengthened through the phenomena that you mentioned, AI and big data? So do you have any concrete suggestions to counter those developments?
Thanks very much for the question. So it's about how do we tackle these problems in the political sphere? And this is a huge question, and I feel like it's going to stay with us for quite a while. So with our friends and in corporations, when we get together, for me it's about how can we support people, how can we visualize algorithms, how can we make people understand what happens there. And our perspective is how can we, open up this black box and how can the system show how secure it really is. And that's a lot of work. For example, there's the fairness, accountability, transparency, machine learning. There's a huge group of people from all sorts of backgrounds in psychology, sociology, and of course computer sciences that deal with these kinds of questions.
Please leave the room as quietly as possible and try to keep using the right door. Microphone 5, please. Well, I'd rather have a short comment. In machine learning, what we've seen with regard to the gorilla example, isn't this an example of the cost function? Since we've said the algorithm, it's as expensive to take the class of gorilla and the class of human, it's as costly as as mixing up also other words? This need to be differentiated a bit more?
Good point. Of course, you can defend against that sort of thing and say, this is worse than that. For example, with Google Photos, where we want to have all these categories, it's also a task for human beings. It's not just about machine learning. And the problem with this bias, and that was what it was about, is more complex, and it's not just about this cost function. Yeah, and the point was also about, there must have been a wrong data point, and then how this bias was calculated in some sort of negative spiral when the algorithm looks at that. And maybe that's, too much simplification going on of reality. And of course, these are really easy examples to illustrate this here. And of course, there's always blind spots, and this might be one as well, because Google might not be diverse enough, and they didn't test their photo algorithm on enough data points before they made it public.
Microphone 1. Thank you very much. I think this is a great approach of putting this topic on the agenda, making it more popular. You talked a lot about bias, and very often when talking about bias, it's about neutral and judgment. And you also mentioned machine learning in that context. And in this context, with regard to political debates, bias and screwing, is that actually the right term to describe political phenomena, or should this be maybe described differently with a different term?
So, we're not all about communications. That's not our expertise. There's people that can do that a lot better than us. But, people like us, we're doing a PhD within this field as computer scientists, how we can deal with these problems. But it's going to be a long-term task to really get this out onto the street.
There's a question from the IRC. Is human learning not comparable to machine learning? Aren't the challenges the same, or are they different?
Do you want to do this? Well, that's a question. It's not just about machine learning. It's also about evolutionary theory and psychology. And I don't know too much about that. But the idea behind machine learning is to find mistakes, communicate them, and then adjust and correct the model. I'm not sure whether that's the case for us humans as well. So, in the sense that our brain is optimized over time, I feel like I've heard psychologists deny that. So the problem with this question isn't necessarily, how does machine learning work, but it's how do we ourselves work. And I think we're still trying to figure that out. And the models of machine learning are very, very rough estimations of how we ourselves work. And so there's, back then there was the thought of, the body as a machine. And now we have these neural networks, and I feel like, and that's the model we apply to think of ourselves. So I feel like there's always some adjustment going on. And I feel like for us as human beings, all the assumptions we make, all the stereotypes that exist, they might be useful from time to time, but in totality, they don't apply all the time. So that might be the case for machines and for humans.
Microphone 4. Maybe a bit naive, but are there metrics with regard to the bias that we see every day in the net, are there techniques to visualize those kind of biases, to make it known so people realize that this is a highly complex topic? And I'm looking for ways of this complex topic being visualized so people know and get aware of those statistical problems.
Oh, there's research for this. There's the MIT Media Lab that deal with this sort of thing. They have examples of individual people, what sort of gender bias they have for the people they follow on Twitter. For example, they only follow males. So that's part of the puzzle, but this sort of media education that has to be taken seriously. If we want to use all these algorithms, if we want to drive around in self-driving cars, we really have to take this seriously. There's always blind spots, and up front, it's not possible to take all of those into account. And for some more context regarding this question from algorithmic science point of view, for us, we don't have we don't distinguish between positive and negative distortion. For us, there's just properties that let us draw conclusions. And when we say that we have certain values that are just proxies for different data sets. For example, where I live is often a proxy for where I am from, or other data points. And so, if I know what sort of data points are sensitive and shouldn't be taken into account to draw further conclusions, then I can feed this into an algorithm and have
dein Bildungsstatus oder dein Einkommen, dass die keine Rolle spielt,
result computed from that. So,
wie der Algorithmus Voraussagen macht.
So to actually see how the algorithm makes predictions.
What I'm really interested in is not the distinction between good and bad, but rather a visualization of data sets and those results. For example, that one is based on a very small number of data points, and others are based on a high number of data points. And this, I think, I'm looking for visualizations of such cases.
Yeah, there are cases like that, and we can measure that, but it's always sort of, a simplification. It's always the question of how easy can we make it, how much can we simplify it. There's this core approach, and that's not about how do I have to think about my hypotheses when I look at the data, but it's more about how good is my data for my hypotheses. So, and this approach allows us to make different statements. So, for example, if I have an outlier data point, then that changes the statement I can make, and then I have to be upfront about it and say that this is a very vague guess. But in the research for that is still sort of doing baby steps.
Microphone one, please. Thank you very much for this talk, and also thank you very much for mutually translating this ongoingly, on a constant basis. I'm interested in your take on how useful those approaches are to take milestones and evaluate the opportunities that those approaches, machine learning and so forth, actually yield for society.
Also das ist eigentlich genau das, worauf wir hinaus wollten.
Yeah, that's what we wanted to get at. It's a political question, and we don't want to answer that, or a question for the law. So it's about society dealing with this, getting together and finding answers.
Yeah, I know, but once you've defined a milestone, a separation between good and bad, and you look at the data points on one and the other side, and if you look at those data points and some are actually relevant and others are not, let's say we have a point X, a milestone with a certain quality criteria attached. Like a car doesn't kill more humans than a human driver. And is there something like values grouped around this boundary that you can draw conclusions from? Or are all those points scattered around the decision horizon?
I think it's problematic to sort of focus on this point because it's about a lot more environmental factors, and then just take this one singular point and draw conclusions from that. That's probably too simplistic, and I once again want to point out the political question. And self-driving cars, you know, they can never test crashes, at least not with humans. So these crash scenarios are only ever tested in simulations. And that exactly is the problem that we have today. At least as far as I know, we have very few scenarios where we have training in certain model scenarios. What assumptions can we actually transfer into the real world? And so even really pointing out these assumptions is very hard for us today, and so it's still quite a long way to go.
Thank you very much. Microphone 1. Thank you again for the talk. The discussion connected to all of this is actually how can we find truth? And how can we make a computer to find truth? We have the same in science, like how do I design my sample? Is there a bias in the sample? Have you ever dealt with this parallelism?
So we're scientists, and of course we have to know for ourselves what we found out. You know, yesterday there was this talk, Science is Broken. So it's always quite hard to have the right sample size and to think of the effect size. And this is an epistemological question.
Aren't there kind of values you can orientate yourself to with regard to neural networks or something? Are there any values you can rely on with regard to layers or parameters?
Well, this question is maybe it goes into, you know, early 90s, early neural networks, Baltimore machines, Hoffman networks, stuff like that. For these, we can say that when they're saturated, how many bits of data were put into that system. But for the non-linear systems that we use today, it's not possible to say that anymore. It's just an estimation. It's not an exact size.
But can't you say you need a certain amount of data points to saturate your system, and therefore we need a sort of pre-validation approach?
Yeah, but that's what happens. You have this huge data set, another data set, and a training or evaluation data set. So where you really have to check, did we actually learn something, or did we just like learn to repeat our input data set? Yeah, so, but this is still a PhD dissertation waiting to be written. Yeah.
These biases are not new. Like, we've known them for decades in statistics. What has now actually changed with artificial intelligence? And in this context, do you know any studies that filter bubbles really have an impact that you can also measure? I've heard a lot about it in the media, but I've never come across any scientific study that has shown that you are actually strengthening and making something stronger that hasn't been there before.
I forgot the first question. Please repeat it.
Okay.
Sure. What has changed with the biases in machine learning?
All right. No, of course, that's not new. And the
Auch aus sehr guten Gründen, also zum Beispiel es gibt hervorragende Python.
assumptions are new as well. So we have
Unis lernen das fast überall.
great, data science is hyped right now at universities, but now people go ahead and throw stuff into their systems, maybe to make money, but don't really think about these problems at all. And regarding the second question, I'm pretty sure there's a lot on echo chambers out there. I'm not sure what you asked exactly, whether it was possible to test this scientifically, how an approach to testing this would work. But I'm pretty sure there's lots of literature on echo chambers, but I can't think of an offer right now.
Vielen Dank für den Vortrag. Ich sehe, dass noch Fragen sind.
Thank you very much for the talk again. I see that there are more questions. Please approach the speakers right after with your questions. Thank you very much, everyone.